Yes, today we're going to be finding the equations of motion for the double pendulum. I'll be using the Lagrangian, right? The Lagrangian right here. And remember that x1 is a function of theta 1 and x2 is a function of theta 2. So we'll be using the Lagrangian to find the derivative, the partial derivative with respect to theta 1 dot, and then the derivative. And then the partial of the Lagrangian with the partial of theta 1 dot. And then we'll be doing the same thing with theta 2 dot and theta 2. I draw a double pendulum right here where you could see the mass m1 and m2. And you can see that x1 is a function of theta 1 and x2 is a function of theta 2. This will be my y1 right here. This will be my y2 right here. This will be my x1, right, opposite to theta 1. And this will be my x2, opposite to theta 2. And we could break the velocity 1 into x dot 1 and y1 dot, and the velocity of mass 2 with x dot 2 and y dot 2. Gravity is pointing down. This is the L1 for my string, the first string, and L2 for my second string. I'll be using the Lagrangian, which is the kinetic energy minus the potential energy. First, this is going to be probably 4 videos. First, I want to find the positions and the velocities. My first position will be x, and x will be equal to opposite to x1, which would be L sine of theta. And this is for my x1. My y1 will be the adjacent, right? The adjacent, which will be L cosine of theta 1. This will be a 1 here too. Then for my x2, now I have to add x1 plus x2, which is L1 sine theta 1 plus L2 sine theta 2. And for my y2, I will have to add the same thing, y1 plus y2. So it will be L1 cosine theta 1 plus L2 cosine theta 2. Now I want to find my velocities, right? My x dot. And my x dot for this right here will be L1 theta 1 dot cosine theta 1. For my y1 dot, it will be equal to L1 minus, it'll be a minus here, minus L1 theta 1 dot sine theta 1. For my x2 dot, it will be equal to this right here. It will be L1 theta 1 dot cosine theta 1 plus L2 theta 2 dot cosine theta 2. And for my y dot 2, it will be equal to, this right here will be minus L1 theta 1 dot sine theta 1 plus minus L2 theta 2 dot sine theta 2. And remember that, I want you to remember that this right here, that cosine theta 1 cosine theta 2 plus sine theta 1 plus sine theta 2. All of this right here, is equal to cosine theta 1 minus theta 2. That's the double angle theorem, right? And what I want to do is, in my next video, is find my kinetic energy and my potential energy, and then go ahead and find my my Lagrangian. And once I find my Lagrangian, I can find all of this right here and this right here for theta 1 dot, for theta 1, for theta 2 dot, and for theta 2. If you like this video, please hit like and subscribe. Thank you.